Good afternoon. My name's Dave Massy, and I'm going to talk to you this afternoon about the new Internet Explorer features that are going to be included in the Whistler release. This is all based on the Internet Explorer 5.5 release that we're planning for this summer. So first of all, I'm going to talk about the general DHTML enhancements that we've got with some improved CSS support. Then I'm going to talk about the component model, some HTML plus time enhancements, and then talk about some new editing features that help make Internet Explorer 5.5 a very powerful platform to develop for. So the goals for Internet Explorer 5.5 are really to build on the success of Internet Explorer 5.0. Internet Explorer 5.0 has been an extremely successful product, being a stable and fast browser, but also being a platform for the development of application UI, not just for connected applications on the internet, but also just for applications that you'd run on the client machine. An example of this would be if you point your Internet Explorer 5 browser to www.halfbrain.com. That's a great example of a fully interactive application that runs purely through script and dynamic HTML loaded on the server that's downloaded to the client. So all you need on the client machine is a version of Internet Explorer installed and no additional binary components downloaded for it. Another area we've concentrated on really for 5.5 is to improve our print quality. And this has included completely replacing the printing code base for Internet Explorer and supporting print preview as well. We've also concentrated a lot on the component model. We introduced a new component model in Internet Explorer 5 based on what we call DHTML behaviors. And we've got a number of enhancements to that allow people to build up their own rich HTML elements. And also we've concentrated a lot on editing, improved editing support with the extensibility hooks so that as a host of the Internet Explorer browser components, you can override and further enhance the editing experience. And of course, we've got the continued focus on performance and robustness to make it a great browser for browsing the internet. So first of all, to talk about some of the DHTML enhancements, we've got some improved CSS support, support for vertical text layout, pop-up object, a feature called colored scroll bars, and something that we call native frame, which allows us to get a greater speed improvement and also have some cool visual effects with iframes. So if we first talk about the CSS support, previously, we didn't honor the borders, margin, and padding on what's known as inline elements within the document. What I mean by an inline element is something like a span element, which wraps across lines of text within the browser, whereas a div element or a table element is a full rectangular block within the browser. So previously, we only honored the borders, margin, and padding on those block elements and not on the inline elements. Now you can set those CSS properties on the inline elements as well. We've also improved support for dotted and dashed border layout. So this is part of the CSS1 specification and the ability to actually specify dotted and dashed borders so you can highlight areas of the content in a different way. We've also included a CSS property for zoom that allows you to zoom in or out particular content whilst keeping it as live DHTML content. This is actually a byproduct of some of our printing support where we've improved print quality and had to actually zoom out and zoom back in to get a really good high fidelity print quality. And so we've exposed that ability on as a CSS property as well. Another CSS1 area that we've improved our support in is support for first letter and first line. Now, this is a CSS property that allows you to specify for a style for a particular paragraph, saying that the first letter is a particular font size, font color, and font type, and the first line can be a different one. And then we'll wrap the text around the first letter to give a more sort of newspaper or magazine style layout. And this way you can do stories with a large first letter, and then the additional text will wrap around that first letter, much as you'd see in a magazine. And one of the, what I believe is most significant areas of support is this ability to do vertical text layout in Internet Explorer 5.5. This is particularly important for Japanese and traditional Chinese markets, where text is typically laid out in a vertical fashion. Previously, these markets would have to resort to laying out their text horizontally, or they'd have to put the text actually into images to get a vertical layout, which is hardly conducive to the timely publishing of content. And so with vertical text, you can actually just specify for a CSS property the writing mode, and we'll lay out the text vertically. When you combine that with the Japanese and traditional Chinese fonts, you can get an appropriate display for those countries. Another feature that we've actually added to Internet Explorer 5.5 is something called the pop-up object. This is answering a problem that a lot of users had when they were developing dynamic HTML content, where if they wanted to position a menu or a tooltip, they could do that by positioning a div element at an appropriate area on the browser. But that div element would always get clipped by the boundaries of the client window. With the pop-up object, you can now generate a pop-up object and populate it with some dynamic HTML content and have it as the topmost instance on the desktop. And so you can get outside of the client area. This is useful particularly for menus and tooltip functionality. And the support is very simple. We have an ability to create the pop-up object, and then you can populate that resulting object with dynamic HTML, and you can then show or hide the pop-up object and check whether it's actually being shown programmatically with the isOpen property. Another thing we've added is the ability to have colored scroll bars. Now, this is a feature that we get two reactions to. One is, why on earth would you ever want to do this? And the other one is, wow, that's cool. And you can kind of tell whether somebody's a designer or a programmer by that reaction. But this is the ability to actually control right down to the tiny little arrows on the scroll bar what the colors of the scroll bar are. And that way you can get a much more integrated color scheme with your web pages. So if you're doing some dynamic HTML content that has a black and sky blue theme, you don't have to have the chunky gray Windows style scroll bars showing. You can actually have an integrated color for your scroll bars there. Now we've got a feature that we tend to call native frame. And this is all about allowing, or in previous versions of Internet Explorer, every frame or iframe was actually another instance of the web browser. And now in Internet Explorer 5.5, every frame is in fact within the single instance of the browser. And so this is actually a much more efficient way of rendering frame content. And this has given us a performance boost on typical frames pages of about 25 to 30%. And on an extreme test case, we've even seen a speed increase of loading the page of 75%. But some of the architectural changes involved in that have even made just the navigation of non-frames pages faster. And so Internet Explorer 5.5 will appear to be just that little bit snappier and faster than previous browsers. The effects that you can actually get through this work, though, is the ability on iframes, inline frame elements, is to actually have them as transparent and z-indexable. Previously, because every inline frame was another window of the web browser, it couldn't actually play properly within the z-indexability and transparency with the rest of the dynamic HTML content. But now, if both the containee and the container say that the background should be transparent, then we can have backgrounds showing through the iframe content. And this way you can have effects such as watermarking of documents that are separate within an iframe, for example. And as I said before, we'll also support the z-index aspects of iframes, which we didn't previously honor. And we've also done a couple of enhancements here for easier access to the frames through the object model. If you're actually hosted within the frame, you can call the window.frame element to crawl out from within the frame and get access to the containing page. If you're actually the containing page, you can call through the ID of the frame element to the content window property to get access to the window object of the contained document. Now, if the content is actually coming from different domains of both the containee and the container, then we will invoke standard cross-domain security, as there are some nasty security scenarios that prevent us from allowing arbitrary access to and from that content. And another area we've improved is on the HTML dialog front. This is totally or only available to what we call trusted hosts, such as a host of the web browser control or an HTML application. And this allows somebody to actually get a dialog to come up without the standard Windows adornments of a title bar and the Windows border. So along with the colored scroll bars functionality, you could actually generate some HTML dialogs that come up as just their own little window, but without the standard Windows adornments. And so you can again get a much more interactive and absorbing application. The reason this is only available to trusted hosts is again for security concerns, so that we don't allow people to spoof standard dialogues and steal passwords and so forth. So now I'd like to just talk quickly about HTML plus time and some of the multimedia effects. In Internet Explorer 5.0, we actually introduced HTML plus time, which is a way of declaratively having timing within a document, so that without having any script within the document, you can say 10 seconds after the page is loaded, fly some text in, and then after that's happened, fly some more text in from the top. And we've enhanced that a lot with Internet Explorer 5.5 to improve that level of synchronization. We've also worked with the W3C committee to have the HTML plus time functionality included in what's known as the Smile Boston draft standard. And this is allowing us to do a much greater level of synchronization. And an example would be if you had a video clip that actually was doing a presentation, and you could have some HTML running alongside it that was the content of the document, and it could be synchronized to certain points within the video clip. And so you can have a progress being updated textually, and you could have my own commentary coming along, synchronized alongside a video of this presentation. And there's we've included some enhancements to the Smile Boston draft, so that all the HTML plus time functionality that we had previously is also supported. And we've also got some extensions to allow authoring tools to get in and author some of this multimedia content, and also support for custom players. So if you come up with your own media format, you can have the hooks there so that the HTML plus time and Smile Boston functionality can synchronize into your own media format. So now I'd like to talk a little bit about the component model enhancements, which has been a major area that we've worked on with Internet Explorer 5.5. The focus being to allow people to develop their own custom elements for DHTML content that can be used as rich and as robust to use as the standard HTML elements in a browser. So as an author of an HTML document, I can make use of somebody else's custom element in much the same way as I'd make use of the standard HTML elements of a div, an input, or a text area, for example. Another area we've worked on is allowing encapsulation of DHTML content for behaviors, and that's something that we call view link functionality. And there's also some additional object model for firing events specifying defaults, and I'll discuss these next. So to recap on what we introduced with Internet Explorer 5.0, we introduced something called behaviors, which was this idea of having reusable scripted content that could be attached to any individual element within the dynamic HTML document. For clarity now, we refer to those types of behaviors as attached behaviors. And so the idea was that using a CSS behavior property, you could attach to any element in a document. One of the problems with that is that it can also be detached, because it's just a very sort of tenuous form of binding to the element. And so we've introduced in Internet Explorer 5.5 something that we call element behaviors, which are very much an evolution of the attached behaviors we introduced in 5.0. But they're all about defining your own custom elements. And by a custom element, I mean the XML syntax of having the namespace followed by the tag name. And the way to think about an element behavior is that the behavior is the custom element, and the custom element is the behavior. So they are permanently and irrevocably bound together and cannot be separated. So the advantage that this then gives you is that they're very robust because we have what we call synchronous parsing. Previously, with attached behaviors, we'd be parsing the document and work out that a behavior needed to be attached, but that behavior would be attached later during the CSS apply parse when the CSS formatting is applied to the document. With element behaviors, you can be 100% sure that the behavior is being instantiated immediately as the element itself is being instantiated. And it also means that the behavior can't be detached from the element. And the way we declare these new element behaviors isn't using CSS, cascading style sheets, but it's using a processing instruction. And here on the left-hand side of this screen, we've got an example of the HTML file that would be using an element behavior. And we have, at the top of the file, we have the HTML tag, which is saying XML_NS:veg. So that's declaring the veg namespace for use within this document. And then we have what's new here, which is the import processing instruction. And at this stage, when we hit the import processing instruction, we stop parsing the document and we fetch the behavior so that we're sure that it's available for instantiation immediately when we need it for the resulting tags. And in this case, we're saying that for the namespace of veg, there's an implementation file which is tn1.htc, an HTML component. And then subsequently, we use the veg::turnip tag to actually show or to actually invoke this particular behavior. And so if we look on the right-hand side of the screen here, we've got the tn1.htc file. So this is a standard HTML component, much the same as we introduced with Internet Explorer 5.0. But the difference here is that we've specified a tag name of turnip. And so when we're in element behavior, the behavior is specifying the tag name, and the user of the behavior in the HTML file is specifying the namespace. And so it's up to the author of the HTML file to avoid tag name conflicts by using different namespaces, but the tag name is under control of the behavior author. And then the rest of the behavior here in the HTC file is much the same as it would have been with an attached behavior. We've got declarations of properties, methods, and events, a script block, and maybe some HTML itself in a body. And so now I'm going to talk about the new encapsulation technique that's available to these element behaviors, which we call ViewLink. And to understand what ViewLink is about and why it's important, we should first recap on the problem that exists with a standard attached behavior. And in Internet Explorer 5, a behavior could actually display some HTML as the sort of display of the behavior. But in order to do that, it actually had to put the HTML into the main document using probably the inner HTML on the element to which it's attached to display some content. And an example of that is something like that we call the calendar or date picker tag, which in order to display some HTML for the date picking, which is rendered as a table, the table and all its contents has to be injected into the main document under the element in the main document. Whilst this works, it does lead to pollution of the main document structure because the author of the document simply put a calendar tag in their document. And suddenly, if they actually have some script that's walking up and down the document, they notice that there's a table in there as well. And they think to themselves, why on earth is there a table there? Similarly, styles can get applied inadvertently. So in that example, if I've got a style rule in my document that says that all tables have pink borders, suddenly my calendar is going to have pink borders as well. And again, the fact that the calendar is implemented using a table is purely an implementation detail that shouldn't have to worry the author of the DHTML document. And so to solve this problem, we've introduced view linking. And this is a concept that's only available to these element behaviors that I just discussed. And the idea here is that there is a separate document fragment that the HTML component will control that would, in the case of the calendar example, would have the table and the interactiveness of the date picking. And the main document simply refers to that other document fragment as being the view for the content of the element. And so we end up with a level of encapsulation there where the table is actually hidden from the main document. It's being used for the display, but the scripts and the styles that are running in the main document will not be able to see that table. And this means that you can develop your own rich and robust, resilient components that somebody else can use within a document without having to worry about how it might interact with the other parts of that document. And so there's a couple of ways that you can do view linking. And the first that I'll show here is the declarative view linking. And here I've got an element behavior that's being defined in an HTML component, an HTC file. So I've got public components, and the tag name being defined for this tag is my tag. And then below here, I've got a body with some internal text within a bold tag saying the content will show up as the content of my tag using viewlink. And this automatically gets shown as the view for this element behavior because I have the public :defaults tag here that is saying viewlink content equals true. And so by default, the content of this HTC file will turn up as the display for the element, for this element behavior. The alternative way to do view linking is procedurally. And so if you've got building up your own dynamic content for a display of an element, and in this example, in the initialization of this document, we have a function called init, and what it does is it does a create element of a bold tag, creates some text node for that bold tag, and this forces the creation of a document fragment. And then off the defaults object, we simply refer to that document as being the view link for this defaults object. And therefore, that content that we've just created turns up and is displayed as as the display for this element behavior. And so you have the choice of either doing some view linking declaratively or procedurally, depending on your particular application that you're trying to build. Another important aspect for the component model is this concept of being able to define the defaults for an element behavior. And the way to think about the defaults is to think about every tag within an HTML document, such as a bold tag or a div tag, is just an element within the document. It happens to have, in the case of a bold tag, a default style of font weight bold. And similarly, the div tag happens to have a default style of display block. And what this means is, as an HTML author, I can actually make a bold tag look exactly like a div tag by specifying specifically that the bold tag has a style of display block and font weight normal. And then it'll look just like a div tag. And vice versa, I can make my div tags look exactly like a bold tag. And so once you understand this concept of these are just default properties that can be overridden in the main document, we see that it's interesting as an element behavior to be able to define your own defaults as well. And so all the CSS properties can be defined as default properties. There's something called content editable that I'll discuss in a little while, but also things like contain selection, is multi-line, and is tab stop. So in the case of is tab stop, if you think about HTML elements in a document, some of them by default are in the tab order of the document, but they can be overridden by specifically specifying the tab stop. And so similarly, when you're developing your own element behavior, you can say that the tab stop is within or this is by default within the tab stop of the document, and then the user of the behavior can override that and set an explicit tab stop should they wish to. And so there's a couple of ways to do specify the defaults. Again, there's a declarative way and a procedural way. And here we have the declarative way where we're actually defining our own bold italic tag here. And all we've done on the public defaults tag within the HTML component is specify that the style is font weight bold, font style equals italic. And that then means that the contents of this element behavior, when it's used within a main document, will always be rendered as bold and italic by default. And similarly, there's the programmatic way to access the default properties. And we expose a defaults object within the element behavior that you can then access. And so you can access all the styles and other properties on this defaults object. And I'd also like to talk now a little bit about editing, because it's particularly interesting within the field of developing your own element behaviors and your rich components. Previously, we've always supported an edit mode within Internet Explorer, but in order to invoke it, you actually had to have the Internet Explorer components already switched into edit mode and then load the whole document in. And we've enhanced editing this time around by actually allowing you to dynamically switch any part of the document in and out of edit mode, simply by accessing the content editable property on the element. And then all that element and all its child elements will be switched into a WYSIWYG edit mode, where you can actually start typing text and use Control U, Control B, Control I to make underline, bold, and italic functionality. And this way you can develop your own rich data input fields, where you can allow people to have all the capabilities of rich HTML formatting and actually change the document structure within the browser. Now, it's important to understand that this is just changing the document structure. How you then persist those changes that the user has made is entirely up to the document author. Maybe they want to submit them back up to a server, or maybe you want to persist them on the client machine using the user data persistence behavior that we introduced in 5.0. But this is a very powerful capability. And finally, to wrap up the component model capabilities, talk a little bit about something we call literal content. And the way to think about this is a style tag or an XML tag or a script tag within an HTML document. The contents of those tags aren't actually parsed and built by the HTML parser. What happens is when the HTML parser is hitting, say, a style tag, it takes the contents of that tag and passes it to the CSS parser, which will then take and interpret that content. Similarly, with the XML content, it'll be passed to the XML parser, and with script content, it'll be passed to the script engine as appropriate. So when you're defining an element behavior, you also have this ability to say the content of this behavior or this element is literal. And at that point, the HTML parser will not try and parse and build the content of that element behavior, but will simply take the whole string of that content and pass it to the element behavior so that it can be built, interpreted by the element behavior. So if you do have some sort of proprietary format of data that you want to interpret and include inline within an HTML document, you have that ability. Although increasingly we're seeing that XML is becoming the ubiquitous format for any data structure being passed around the browser and between businesses. And then there's a bunch of other new stuff that's not necessarily for scripting and DHTML content authors. We have this ability, because a behavior component is in fact just a COM object. There's a lot of new or there's a set of new rendering and layout interfaces that are specifically for binary behaviors. And so if you're writing a behavior that's a COM object and has access to binary code, you can do your own rendering, and the new layout negotiation interfaces allow you to specify the amount of area that you need to draw your particular shapes and content. We've also moved the filter and transition code that's been included since Internet Explorer 4 to make use of the DirectX transforms codebase. What this actually means is that in a very simple declarative fashion, we can do things like a gradient fill, where we start off with a dark green and fade through to orange. And that can be done with a very simple declaration, whereas previously, if you wanted to do gradients, you'd have to download an image to get that sort of effect. As I mentioned before, we've also done a lot of printing improvements so that we don't have some of the problems of clipping text that we had in previous versions of Internet Explorer, and also support for print preview. This is actually interesting. If you are a host of the web browser components, you have the opportunity to override some of that print preview functionality and provide your own print template into which we'll pour the document for pagination. And so a host can actually customize the printing experience for the user. And finally, I'd like to talk about editing for hosts. So previously, as I mentioned before, MS-HTML DLL was available for editing, but you'd have to host it, switch it into edit mode, and load the document. We've actually done a lot of work, as I mentioned before, with the content editable functionality. But we've also improved support with things like multiple selection for controls. So if you've got a number of different elements on a page, you can multiply select them, resize them live, and so forth. There's also support for custom glyphs. So if you happen to have your document in a WYSIWYG edit mode, you can supply your own particular, what we call glyphs, or little icons that will appear next to appropriate parts of the document, and allow you to select and highlight certain parts of the document in order to really show sort of document structure and the full WYSIWYG editing mode at the same time. And finally, talk a little bit about something that we call editing designers, or these pluggable editing DLLs. And as a host, you can actually have the ability to override and improve the editing experience of the users. And so whilst we won't include this functionality in Internet Explorer as it's delivered, these hooks are available for a host to actually add value. And examples of that are WYSIWYG table editing. By default, when it's in edit mode, we won't do full WYSIWYG table editing, but there's the ability for a host to actually add value here. And so you'd be able to have live resizing of columns and rows and get full WYSIWYG editing functionality on your tables. Another example is background spell checking, being able to background spell check a document that's in edit mode and draw the little squiggly red underlines appropriately on the words that are misspelt. And so this sort of goes to emphasize that we're not just a platform for rendering rich content, but we're also a platform for actually entering and designing rich content as well. And so this is sort of further goes to show how we're moving this whole idea of HTML and DHTML formatting into the desktop. And so you as application developers or content developers can rely on this functionality being within the operating system. And our own HTML help system is now fully based on HTML, and add remove programs in Windows 2000 makes great use of dynamic HTML to do all the rendering for those particular applications. And so, sort of wrapping up here, a great place to go for resources. We recently launched a second beta, or second public beta, of Internet Explorer 5.5. And at the same time, we also launched a full developer center on MSDN. And so if you go to msdn.microsoft.com, under the developers centers, you'll be able to find the Internet Explorer Developer Center. And there you'll find access to the full download of the current beta. You'll find full overviews and articles, much covering what I've discussed today. And of course, you'll get full reference access to the documentation for dynamic HTML that's been available on MSDN for some time. But the new Developer Center gives us a focal point to actually bring a lot of this technology together. And of course, there's full samples up there as well. And indeed, there's an article currently up on the Developer Center that I wrote that covers much of what I've discussed today, and also incorporates a lot of samples and pointers off to the relevant reference documentation. And so that's a great place to go to learn more about the capabilities I've been discussing in Internet Explorer 5.5. And so the call to action is really sort of think very hard when you're looking at Internet Explorer 5.5, how you can componentize your application and build element behaviors using ViewLink to actually generate a great componentized application, so that you don't have to have a lot of code and script on each individual page of an application. Think about using some of the new visual effects, colored scroll bars, the transparency indexable iframes to give you some visual effects there. The new Smile Boston HTML plus time support, allowing you to get multimedia content included in a very declarative way. And most importantly, give us your feedback. We need feedback on the product, particularly on compatibility issues. Compatibility remains a very great concern for us. We think that we've managed to make Internet Explorer 5.5 fully compatible with the 5.0 product. But if you don't tell us about particular areas, we might not discover them all, because it's a very complicated product with a complicated feature set. Give us feedback on the new features, and also, very importantly, on the documentation up at the new developer center. We do our best with the documentation, and I think our documentation team does an excellent job, but it's important for us to understand what areas of the product don't make sense, what areas would another sample help with, where would an overview article help in explaining some of this new functionality. And at that point, I'd like to open it up for any questions that we have on the machine over here. Okay, so looks like we don't have any immediate questions here. If you want to forward them on, I'll be able to answer them later offline. Thank you very much for your time today.